Welcome to solverfy.
So in question 8.132, we're given two belts, A and B. We're given the angle here as 15 degrees. The radius of belt A to be 120 millimeters or 0.12 meters. The radius of belt B to be 50 millimeters or 0.05 meters. The static coefficient of friction to be 0.4. The maximum allowable tension to be 450 newtons, so basically T2 to be 450 newtons. And we're told that this is a V-belt problem with the angle alpha to be 36 degrees. So to solve this problem, let's first go ahead and calculate the angles beta A, beta B, basically the angle between the center of the drum and the belt. And then once we calculate that angle, we can then determine the tension and then use that to determine the moments. So for the angle beta A, we basically have 180 degrees plus 15 degrees in either direction. So beta A is equals to 180 plus 30 degrees. That's equals to 210 degrees. So beta B is basically 360 minus beta A, which is equals to 150 degrees. That's equals to 2.618 radians. So now we see that beta B is smaller than beta A. So basically, slip is impending on belt B. So let's use the impending slip equation on belt B to calculate T1. So we have the maximum allowable tension, 450 over T1, to be equal to E to the static coefficient of friction times the angle, which is 2.618 radians, over sine of alpha over 2, or 18 degrees, because this is a V-belt impending slip problem. And so from this equation, we get T1 is equals to 15.19 newtons. And now to calculate the moments about A, we take the difference in the forces T2 and T1, and we multiply that by the radius. So we have 15.1, we have T2, which is 450, minus 15.19 newtons, times the radius, which is 0.12 meters. So that gives us our moment or couple to be 52.2 Newton meters. That's our final answer.